All right, Allison, so I'm going to do part D now. Hopefully my brain is not as crazy as it was this morning, and we can work through it from start to finish without any problems. So part D says, for 0 to 8, is there a time t when the rate at which the water is pumped into the tank is the same at which water is removed from the tank? Okay. All right, so let's write that out. So before I had said that we need to figure out, is R of t ever going to be equal to W of t? So this is the question. Okay, R of t is given as a table, and W of t is given as a function. So one of them we're going to use the points right from the table, and the other one we're going to actually use our calculator. All right, so the issue is we don't know how to graph R of t, because if we did, we would graph R of t and W of t and just find where they cross. We do have two endpoints though, so we really have like two different scenarios. However, another way to discuss this is if those two things are equal to each other, that means R of t minus W of t would have to be equal to 0. Okay, so now the interval we're looking at is from 0 to 8. So we're going to like split this up into 2 times. We're going to say, okay, well, R of 0 minus W of 0. Let's figure out what that is. And then we're going to do R of 8 minus W of 8. Okay, so do I still have it in my calculator? Let's see. So, well, R of 0 is 1340 minus W of 0. So W is going to be 2000 E. No, it's not here anymore. 2000 E to the negative t squared over 20. Negative. So t is 0 squared and then divided by 20. So that gives us 2000. So 1340 minus 2000. So 1340 minus 2123 is going to be equal to, no, my goodness gracious, 1340 minus 2123 is equal to negative 660. So this is negative 660. R of 8 was 700 from the table minus W at 8. So W at 8, we would use this up here. But instead of that negative 0 squared, it's going to be negative parentheses 8 squared. So that's that value right there, 81.5244. 81.5244. So 700 minus that value is 618.47. So this is 618.47. Okay. So this is intermediate value theorem because we're discussing from 0 to 8. This is the function they gave us as a table. This is the function they gave us as a function. And they do say in the beginning there that it's differentiable. So if it's differentiable, that means it is continuous. And it also gives us this right here. And we know that this is also continuous over all reals. So we need to know that R of t minus W of t is going to be equal to 0. Well, negative 660 comes out to be a number that is less than 0 because it came out to be negative 660. And this right here came out to a positive value, so we know it's greater than 0. Okay, so therefore it's going to obviously be equal to 0 somewhere along the way. Okay, so therefore R of t minus W of t will be equal to 0 by IVT, since R of t and W of t are continuous. All right, I could have said that in the beginning because in order to apply a theorem, first you have to state that they're continuous. If it's the mean value theorem, you have to also state that it's differentiable. But in this case, intermediate value theorem just discusses continuous functions. It doesn't talk about anything about the derivative. That's how I know it's intermediate value theorem, because we're not doing any of the derivatives here. Okay, these already are given rates. They are given functions. We're not working with their derivatives. Therefore, it's intermediate value. All right, hopefully that answered your question. I'm going to upload it to YouTube and then just email you with a link. All right, hope work was good. Talk to you soon. Bye-bye.